So welcome to today's webinar that will be promising to illuminate the world of DC switching solutions to you. I'm delighted to introduce to you our esteemed guest speaker, which is Marian. She's the current product manager behind Socomec's remarkable DC switching range. Marian brings a wealth of experience and expertise to the table. Before she joined Socomec, she was also a product manager at Hager, where she looked after electronic wiring accessories, demonstrating her dedication and unwavering commitment to the driving force advance in this field. So if you're ready to switch your curiosity and plug into the future of DC power management, you're in for a treat. Marian is here to expand your knowledge and take us on a captivating journey to Socomec's innovative solutions.
Great.
100%.
Great, fantastic. So, welcome everyone to this Socomec PV webinar. So, as it was said before, I'm Marion Vaxelaire and I'm the product manager at Socomec for all the DC switching. And today we're going to talk about PV applications. So about the agenda of today. So first I'm going to talk about the different architecture that we can have in PV application and also explain you the different level of a PV installation. And then I will focus more on the Socomec side and also what are the different technologies that we have for PV and also offer a solution for PV installation. But before that, just a few words about Socomec and our expertise in DC. So Socomec has more than 20 years experience with proven technologies in DC power switching and monitoring. So Socomec is really seen as a DC specialist. So we also put a lot of time and money with new development in R&D to develop new DC products. So we are really an innovative company. Socomec also pioneering different DC patents and world first product, like it was the case with Circuit DC, which is a 500 volt DC capable product, breaking capable product, and also with Inosis, which was the first product with a 1500 volt DC product capable in only 2 poles. When you heard about DC, you all know that our future will be more electric, more sustainable, and more focused on DC distribution. And at Socomec, we are present in different types of DC applications. The most known one is, the most famous one is the renewable energy with PV, battery protection, and also energy storage. But we are also there for DC process, drives, and power electronics, DC distribution, and more in e-mobility, with electrical vehicle and also marine. But today, we're only going to focus on photovoltaic, so PV applications. So let's go now straight to the matter. So let's start with some vocabulary about PV application and also how we can gain some power. So you all know how it looks like a PV panel, but how it works in terms of power. So in a panel, you have different cells with a really low amount of voltage and also current. And we're going to put all these cells in series in order to have a module, or what is commonly said, a panel, in order to have more voltage, but still the same amount in terms of current. Then we're going to put all this panel in series again in order to have a PV string, in order to gain, again, more voltage, but still the same in terms of current. And then we're going to put this PV string on in parallel in order to have still the same voltage, but increase the current. So that's really the basis in terms of PV. Now, let's talk about the main architecture that we can have in PV installation. So I just put the pointer like that, it's going to be easier. So really, the architecture in PV will depend of the power of your installation. So on this slide, you can see the different type of installation. For a PV installation, we only go up to 15 kilowatts. So it's really installation for small building or residential buildings. So you will have your strings, your different panel, then it's going to go straight in an inverter and then off the grid. Or you can have the option where you have the PV strings, which will go to a combiner box, then to the inverter, and then off the grid. Now it is the different architecture that we can find for commercial and solar parks, so above 15 kilowatts. So you can go to megawatts or even gigawatts. So you can have 3 different types of installation, PV installation for this type of power. The most common one is this one. So you're going to have your different PV string in parallel, so an array, which is going to go in a combiner box. Then you will have different combiner box, which is going to be put in parallel and go straight to the inverter and then off the grid. You can have also an architecture when we're going to add a level. So same, your array, go to combiner box, put in parallel, then it's going to go to a recombiner box, then to the inverter and off the grid. Another possibility, which is a bit less common, but it exists, that you can have your array, but then put in a string inverter. So it's going to be put in AC, and that goes straight to an AC recombiner box, and then off the grid. So that's the different possibility that you can have in solar parks. That's basically what we have the most at Socomec, where we sell most of the product. So I really talk about combiner box, recombiner box, inverter, but what is the role of this different level in the installation? First, what is the role of a combiner box? So the role of a combiner box, it's easy. It's to bring the output of several solar strings together. So each string conductor lands on a fuse terminal, and the output of the fuse input and are combined onto a single conductor in the switch. You can see that also in the picture, where you're gonna have, you can see the different fuse. So your conductor, the string conductor, which is gonna go on the fuse, and then it's a single conductor which goes on the switch. So positive side, negative side. So that connects the box to the inverter via a switch. So, and what type of switch you can put on a combiner box? So really the most common installation is to have 24 strings in parallel. So you're gonna have this amount of current, so 350 amp or 400 amp in a 1500 volt DC application. Even now, actually, it can go even a bit higher. So sometimes you can even have 500 amp product. So that's for the combiner box. Now about a recombiner box. Actually, a recombiner box, it's just a larger combiner box. So the role is exactly the same as a combiner box, but this time instead of combine PV strings, you're gonna combine string combiner box before the inverter with a low break switch. Really, this type of installation is really mainly for UL market. So if you go on a PV farm in the US, you will see all the time a recombiner box, which is really less common for European or African markets, but it's always good to know. And the specificities of a recombiner box is that you can have it in a separate enclosure, like you can see in this picture, or integrate in the inverter. And what is an inverter? So the role is, of course, to convert the direct current output of a photovoltaic solar panel into a utility frequency alternating current that can be fed into a commercial electrical grid or off electrical grid electrical network. And depending of your type of installation, also the power of your installation, you can have different type of inverter. So you can have a micro inverter, a string inverter, modular inverter, or a central inverter. And this one is really a central inverter, and it's really dedicated for big solar and commercial parks. So for this different level of the installation of a PV installation, you can find a load break switch that we can manufacture at Socomec. But what is exactly the role of a load break switch? So it has different functions. The first function, of course, it's the switch function. So to be able to switch on or off the load, just like you do at home with a lamp, but also to be able to make an emergency shutdown. That was for the switch function. But you also have a disconnector function to provide safety and isolation. So like that you can be able to isolate the load for maintenance and also be able to padlock a feather to protect the people who's going to do the maintenance. So that together, it's formed the switch disconnector. And you can add that a fuse protection, like that you're going to have the protection function, like that you are able to protect both the people and your installation. And what are the norms associated to a switch disconnector, so a lock break switch? It's the IC 6947-3, and also for North American market, the UL 98B. So for DC application, for PV application, of course, we use DC switches. But what is really the difference between a DC switch and an AC switch? So for DC, it's of course more difficult to break because it's a linear curve that you have instead of an AC where it's a curve. So when you open DC, of course, it's going to form an arc, and the arc interrupt the current. And due to this electrical arc, you're going to have an intense heat and light, which can have a devastating consequence, just as fire or damage the installation. So in order to interrupt the arc, we can use different braking technologies. When in AC, you don't need to interrupt the arc because you have this natural current zero crossing twice in an AC cycle. So there is no need to interrupt the arc. So in order to interrupt the arc, we can have different braking technologies in DC switches. So the most old one is the arc chamber with a 250 volt DC per pole braking capacity. So that's derived from AC switches. That was the most common one in the past for DC application, and it was really adapted for voltage up to 750 volt DC, even if you can use it also at 1000 volt DC. So how does it work? When you have the arc, it's going to go up to the arc chamber and cut in slices the arc and then extinguish it. Then we have the magnet braking technology, which is a 500 volt DC per pole braking capacities, which is really the technology in PV switching that we have really before the new technology that I will present just after. So that was really common, and it allows also to reduce the number of poles compared to the arc chamber braking technology, and so decrease the watt losses. And it was really adapted for voltage up to 1000 volt DC, even if you can use it at 1500 volt DC. So how the technology works? When you have the arc, the magnet push the arc and extend the length of the arc in order to extinguish it. And the final braking technology, we have really the ultimate solution that we have with our famous range Inesis. It's a combination of these both technologies, so arc chamber plus magnet. And thanks to that, we have a braking capacity of 750 volt DC per pole. And we were really the first one in the market capable to provide this type of solution. So like that, we can have a product at 1500 volt DC in only 2 poles. So that's for the braking technologies. So now let's go a bit more in detail, offered at Socomec and what we can provide as a solution at the different level of installation that I've just talked before. So for PV inverter and combiner box, we have first the Socomec DC, which is a motorized product up to 1500 volt DC. So the range starts at 250 amp up to 3600 amp in IEC. It has different UVP, so the high performance switching, because you can have really high short circuit resistance. The reduced total cost of ownership. So why is it that? Because as you can see on the picture, it's a new model of Socomec, and we have decided to reduce the size of the frame. So thanks to that, we have also a wiring which is easier, but thanks also to the reduced frame, it reduces, of course, the sustainability, the footprint, and also you have that smaller enclosure and also smaller packaging, so it reduced totally the cost. And also an application tested design. It's because we have tested the product through a harsh environment, because in PV, of course, you're going to have your product outside. You can have high humidity, high temperature, high altitude. So we have really tested it against all these harsh environments. So it's really a product which is made for this type of application. Then we have, still for PV inverter and combiner box level, we can have the Circuit PV and the Circuit DC, which are manual load break switches up to 1,500 volt DC. So the range starts at 100 amp up to 3,600 amp. So you can have different type of design. So this one is the Circuit DC. So it's actually the same design as the previous one, so the Circuit mod. So you just don't have the motor, so it's a manual version. And the Circuit DC, which is another version which with the 500 volt DC breaking capacity, which is really focused on the price because it's a less expensive product compared to other technologies. Still, the high performance switching UVPs, the reduced total cost of ownership thanks to this design to have higher rating. And also the application tested design, since it was also tested against harsh environment and high short circuits. And now this is really a famous range for PV application, where we have lots of business everywhere in the world. So Inesis, which is also a range, a manual load break switch up to 1,500 volt DC. We also have a special design for ESS, but I won't talk about it too much. So it starts at 160 amp up to 1,600 amp. And we have also different UVPs, so still the high performance switching, since it was the first product in the market, as I said before, to be able to have a 1,500 breaking capacity in only 2 poles. Also the fact that it's focused on safety, because as you can see, we have this visible blade. So like that, you can really see the state of the product, if it's open or closed. Still the application tested design, and what is really particular with Inesis, we are DC PV2. It's a strong utilization category. I will talk about that just after. And also an easy integration and a modular solution, because you can adapt the product. So as you can see on the picture, you have 2 poles on the right, but you can also have 1 pole on the left, 1 pole on the right, 2 poles, 2 poles, 0, 3, 3, 3. So it's really modular, so it can adapt to the requirement of the customer. And what we have also on this application, you can have a side operation. So on this product, you can have front operation or side operation, which is not the case with the previous range that I've just shown before. So if we look more in the UVPs in detail. So as I said before, it's a large offer, a modular offer. If I can just put the video on, just a sec. Yeah, you can see that it's really modular, so you can have different type of possibility with this product. As I said before, it's a only 2-pole product for 1,500 volt DC capability. Of course, you can add more poles, but you can achieve 1,500 volt DC in only 2 poles. And this utilization category, so DC PV2, which is a really strong utilization category, it's the highest utilization category for PV. So it's a utilization category really has been made for IEC standard, really dedicated for PV applications. So we have to do this harsh environment test to prove that it works in high altitude, high temperature, high humidity, and so on. But you also have to do a more important making a breaking operation with a higher nominal current. So in DC21B utilization category, you're going to test the product only at 1.5 the nominal current. When in DC PV2, you're going to test the product, so making break 5 operation at 4 times the nominal current. So if we take the example of a 400 amp switch, in DC21B, you're going to test the product at 600 amp, but at DC PV2, you're going to test the product at 1,600 amp, which is definitely higher. So it's good to see the performance of the product. And also you're going to have more operational performance. So the number of operation is not the same either. So in DC21B, you're going to have to perform only 1,000 operation, when in DC-PV2, you have to do 5,000 operation. So it also is also proof the performance of the product, and it can also be a warranty for your customer to see, look, we have done this number of operation, we have this DC-PV2 utilization category, so it's really a product driven by performance. So it's a really, really good product, as you can see. So that's for Inesis. It's really a famous range. And now I will just talk about Circo MCPV. So it's a bit different compared to the other range that I've just shown before, because this one is more dedicated for residential, small building. It can also be for solar park, but this one is really made for smaller installation, because it's only a range for small rating. So for the moment, our range, our MCPV range, only go up to 600 volt DC and 1000 volt DC. Start at 25 amp up to 45 amp. But next year, we're gonna extend our range, have a totally new MCPV range, which is gonna be up to 1500 volt DC. So like that, we can also have different possibilities. So still the same UVP, high performance switching, the fact that it's the most compact solution in the market, so it's really small switch, and also easy to integrate thanks to this small size. So in terms of rating of this new range, so it's gonna be also DC-PV2, which is really good for the performance. And we're gonna propose different type of ratings. So still a 1000 volt DC product, but at 50 amp, and a 1500 volt DC product at 32 amp. So that's for the different range that we can offer in PV at Socomec. So that's it on my side. Thank you for your attention. And if you have questions, feel free under to answer, if I can, of course.
There we go. Marian, thank you very much. I think that was very, very informative. I think you did an extremely well presentation, because I see there's no questions. So I assume you got the message over to the attendees very, very well. Or one or two, or they're afraid to ask questions.
Oh, it's okay.
Intimidated by a woman.
Okay, they can go on. So I don't know how it work if I go in the Q&A, or if they speak to the question and I just answer like that.
Yeah, we've disabled the chat function because all the questions go through the Q&A session.
Okay, sure. So let me go then to the Q&A.
And then we've also got Mary, which is based in South Africa, to assist with any questions if we need to.
Okay, so let's just answer the question. So the first one, hi there, please advise if on the ordering of this product, the handle need to be ordered separately. So yeah, the product is sold as it is without the handle. So you have to order the handle separately. So you can have different type of handle if you want the direct operation, or if you need an external operation, so it's not the same handle. So you have a list of, at the catalog, you have different type of handle. So of course it has to be ordered separately. Then I think that's okay. Then
yeah.
Why
so
should yeah
just on my side, oh, there's more questions. Okay. Why should you use a breaker instead of a fuse?
You mean a fuse instead of a breaker? Instead of a circuit breaker?
I think that's personal preferences. Fuses do have their advantages. Breaker does have their advantages. So it's
it's more quicker than
fuses.
a circuit breaker.
Yeah, yes, for sure. Unfortunately, it's a bad question to ask me because I'm a circuit breaker guy. I prefer the circuit breaker than the fuses. But for sure, the fuses do definitely have their place in the market. They are obviously, you can get them at a higher fault level rating. They are faster. The negative part of it is that it's not resettable, and we've seen some pictures where guys put whatever they can into the fuse holder just to get the current through it and cause a lot of havoc afterwards.
Yeah. Then how available are this product in South Africa? So they are available everywhere. So no difficulties normally to.
So the only difficulty there would be maybe the Inesis one, the new one. But otherwise, if they look at the ElectroMechanica catalog, we try our best to whatever is in the ElectroMechanica catalog is to have that available and in stock.
Then what is your recommendation for 48 volt? Oh, I would be curious what type of application is that? But basically, when we have a 1000 volt product or 1500 volt DC, which a specific rating, for example, 650 amp, of course you can use it with a smaller voltage. But this one is really particular, so I really want to know which type of application you want this type of small voltage, low voltage. But normally you can use it. So if on the catalog you see a 1000 volt product, which is 650 amp, then you can use it with a lower voltage. Then is there a configuration tool available for selection? For the moment, no, we don't have it. So we just have the catalog pages and PPT presentation. So that's it, sadly. But what we did in general when we want to advise a product to a customer, so basically we're asking, of course, the voltage and also the current, and based on that, also the number of pole, what is the most important for them, if it's the number of pole, if it's the performance, if it's the price. And then we just offer the switch thanks to this information.
Yeah, sorry, just to interrupt there. Although the Socomec might not have a configuration tool for DC switching, if you go into their website, they also do have configuration tools for other stuff, for like on the metering side. We can help you to do the metering part of it.
One, but not for the DC switch.
No, it's not for DC switching. Yes.
Maybe one day, hopefully. Then, are any of the DC isolation products available in fuse switch version? So for the moment, what I present is really the DC switch and the fuse, which is a port. But we have not for PV, we have what we call an LMDC product, which is a fuse combination switch. But the rest of the range in fuse combination switch is only in AC. But I think it's going to come because we see lots of potential in DC. So it may come. But for the moment, it's only the switch plus the fuse. Except for some application, it's more for drives application where we can find this LMDC product, or for ESS application.
Okay. Yeah, then Steve, your I'm not sure what the question is on the handles that we do not have stock of it. Yeah, unfortunately, these things do happen once in a while. We really do our utmost best to try and keep whatever is in the catalog in stock. But I'll contact you afterwards, and we can take this offline, and we can discuss and see how we can assist you in your problem that you've got. I really do apologize for that.
Just a common one on the problem we have installer using AC fuses instead of DC fuses. Oh, do you guys find the same situation? I've never had this type of problem for the moment with my small experience at Socomec for the moment. But what you can find interesting is that we have now a joint venture with a fuse company. So we're going to have DC fuses as well in the future. It's not right now, but we work on it. So what we have in mind is to offer both the switch and the DC fuse as well, like that the customer can have both of them. But for the moment, no, we work quite a lot with MERS, CBA, Busman in terms of DC fuses. Does this switchgear have current interrupting capacity? Yes, it has. And I am keen on understanding the PV installation architecture because we are about to install hybrid solar installation. So what's the difference between a solar inverter and a hybrid inverter? That's a good question. To be honest, I don't have the answer.
Yeah, we need to speak to the solar guys that does the inverter part of it.
Yeah.
So, Maria, I just want to go one step back to the previous question. Do these switchgear have current interrupting capabilities? I assume they want to use this in an installation where they want to do cascading, maybe discrimination, stuff like that.
Okay.
Or either is referring to the KA rating, the fault level of these products. So fault levels is in the catalog under the different utilization categories and different voltages, if I'm not mistaken. So I just need to find out whether they want to do cascading or the reason for the question.
Okay, yeah, maybe we need more information because like that, it's a bit hard to answer.
Yeah, so sorry, is then posted, do these switchgear have current interrupting capabilities for overload and fault conditions? So KA rating of the products, yes, they do have at different voltages, if I'm not mistaken, Marian.
Come again, because it just cut.
Interrupting capabilities for overload and fault conditions. So it won't have for so yeah, so they've got a interrupting capabilities that's tested under 1 second and 3 seconds, if I'm not mistaken, at certain voltages and certain currents.
So yeah, we have so we can have a withstand or short circuits in. Yes. So yeah, so basically what is in the norm in the standard, so it's basically 1 second, so that's 1 second basically, and the level of the withstand is basically offered like 10 kiloamp for kiloamp, yeah, in INSIS, for example. So I mean, the short circuit element for solar, it's really low. So basically, it's like 10 times the nominal current. So the switch breaking capacity is really good. So I mean, to withstand the short circuit, and then the fuse is there to protect the rest of the installation if the short circuit is higher. But basically, what is dangerous in a PV installation is more like the reverse current. But in terms of short circuits, it's not that high, so basically the switch can just handle it, if I answer the question.
If I'm not mistaken, it's got a ICW rating, which is a withstand short circuit.
Yeah, ICW, yeah.
Yeah, yes.
So yeah, ICW, yeah, basically it's 1 second withstand, and the amount for INSIS, it's 10 kA. And what is really an obligation, which is states in the standard, so in IEC, it's like you have to withstand 12 times the nominal current. So we are above that.
Okay. That's good. So I think we're also getting to the end of our time. We can wait another minute or so if there's any more questions that everybody wants to ask. But so far it's been very good. So thank you for all the questions. It's really appreciated. It makes life easier on this side when you're speaking to a screen, you don't know who you're talking to. So thank you very much for the interaction and the questions.
Yep.
Okay.
Well, thank you so much for your intention. I hope you learn a lot of things about PV. And yeah, let's do great business with PV, because I understood that it's like a booming market in South Africa. So yeah, hopefully we're gonna do a lot of business together.
No, for sure, for sure. It's really going very well with the solar industry within the South African market, for sure. Yeah, yeah. For the guys that are still on the call or on the webinar, watch the space, because there's another 2 webinars coming up that we will be doing. I think one is in 2 weeks' time, and then another one in 4 weeks' time. The one is from, if I'm not mistaken, VLAND, and then the last one will be from a company called Surprotect CPT, which is surge protection devices within the DC PV market. Okay. Then if there's no more questions,
I think that's it.
yeah,
Oh.
I'll then.
Yeah. Well, thank you to all of you. Then if there is no question.
Marian, then thank you from my side. Thank you for Socomec for assisting with this webinar. Mary for the support to the background as well. Thank you. And to the ElectroMechanica team in Sandton. Thank you very much, everybody. Then enjoy the rest of your day, and yeah, we'll talk again.
Yeah, thank you so much, and have a nice day, and hopefully it was helpful.
Thank you.
Thank you.
Bye-bye.